Hello, I am Mitch Szewski, and this is my Data Mining 1 project for Dr. Brightsman's Rowan class. I will be exploring the relationship between tweets and polls using sentiment analysis. Alright, so my project objectives are to investigate the use of Twitter data of the Twitter data archive as the input to a presidential candidate's sentiment analyzer. I will train and test a classifier with candidate tweets to assess sentiment that can either be positive or negative sentiment. I will compare Twitter candidate sentiment over time with real clear politics poll data, and I will determine if the Twitter sentiment can be used as a leading indicator to national poll data, as well as assess the impact of retweets on overall sentiment. All right, so how this project all starts is you got to get your tweets. So unless you're lucky like me and Dr. Brightsman is willing to share his election stash of tweets with you, you're going to have to mine them using the Twitter API. Then from there, you're going to do some pre-processing, which is what I will get into that a little bit more. From there, I took the data and I broke it up into training and testing and prediction data. So the training and testing was later broken up into a training set and a testing set. However, these were tweets that I manually assigned a sentiment to and then sent through the naive Bayes classifier to train it. Or for the training data, for the testing data, I will later use that to train the naive Bayes classifier. All right, and the prediction tweets are the tweets I will send through and have the classifier judge and give a sentiment to. This is the majority of the tweets. All right, so the pre-processing, first I broke them up using Python to individual words. I removed punctuation, I removed stop words, and then I brought them all back, or I brought the tweet back together, and then I would send them to either be training or prediction tweets. Training, testing, or prediction tweets. All right. From there, there wasn't too much cleaning to do of the data. The API gives you pretty great, pretty much all you need as far as information pertaining to the tweets. However, there were there's spaces between days. So in cases where there were two days missing, I copied tens, or for the 9th of August I copied up and I gave it 10's sentiment, and for the 7th for the 8th I gave it the 7th. For the 19th of October I just took the average of the 2 days in between. So for the Bayes classifier, that is the classifier I used to do the sentiment analysis. All this is a little bit about Bayes, a little bit about the classifier. However, what's really important is why I decided to use the classifier, and that is because it's less computational. It's less computationally intensive for the CPU and the memory. It requires a smaller amount of training data, and the training takes a little bit less time. So here's a bit of code from my actual running the Bayes classifier. So I had to import this division function, and that is so Python will give you a whole number. It will always round to a whole number if you don't have something like this. So this will give me decimals, and that's exactly what I wanted, because I need to know the percentage sentiment. Here's my BayesNet classifier, and this is just a little look at the code. Over here is all of, or not all of, but a bunch of the training data. Below it is the testing data, and below that is some more stuff such as summing the sentiment across days. But that's just a teaser. So as far as sentiment analysis, we talked about a lot of this. Training tweets, and then we use the test tweets to gauge the accuracy of the classifier. Finally, we send the rest of the tweets through and see how the sentiment is measured each day, and we can make results and do data analysis from there. Here's an example of the Python output. So over here, it tells us our total negative sentiment. Here we have our total sentiment overall, so 31% positive. And this is for, I believe, Clinton without retweets. Yes. And here is the accuracy given by running the test data through and seeing what the actual was. And then here is words it felt carried weight as far as being more corresponding to negative tweets and more corresponding to positive tweets. I used the sliding window average to smooth out the sentiment, because with Twitter sentiment, you can get very big drastic differences between days, such as like days there's 20% sentiment and days where there's 80% sentiment. It could be a little random or seem a little random. To smooth this out and make it look nicer and so it was workable, I used a sliding window average, and that I took the previous 3 days of sentiment, the next 3 days of sentiment, and the current day of sentiment, added that all together, divided by 7, and that gave me what I was going to use as that current day's level of sentiment. Here are a few word clouds I made to kind of get a better look at what were the most used words. So for Clinton, we see FBI, WikiLeaks, we see Bill. Here are hashtags. We see I'm with her, never Hillary. Twitter feeds. We've got real Donald Trump, Hillary Clinton, Breitbart, Fox. And then here's the same with the Trump tweets, with the Trump hashtags, and the Trump Twitter feeds. All right, here is a poll of polls I got from Real Clear Politics. This is pretty much exactly what you would find there. I didn't do too much to this other than adding these dates, and we're going to see these later on. A is the first debate, B is the Access Hollywood tape, C is the second debate, D is the third debate, and E is Comey's letter to Congress. So we can compare Clinton's polls versus sentiment here. This isn't super interesting, only because the polls don't move very much and we see the sentiment move a lot. And I'm going to address this on the next slide. But there are some things I would like to discuss here, and that is that the Clinton retweets data is more often positive than the not retweets data, and overall it was 3% more positive. And also important to note is we see after the Access Hollywood tape, Clinton's sentiment actually goes down, and so we can kind of see that because Trump's sentiment is going down as well, that doesn't necessarily mean Clinton's sentiment is going up. It's just a little interesting. Here we have, I normalized the data so I could see more of the trends in the polls. So just a reminder of what normalization, or I use min-max normalization. And so that's just comparing the current data you're analyzing to the minimum data as well as the maximum data. So we get to see it kind of compared to itself across these dates. And here is where Clinton was lowest in the polls. Here's where she was highest in the polls. And here's where she was lowest in sentiment. And here's where she was highest in sentiment, right in the July 25th. So we can also see Trump against the sentiment. But actually, let me do some analysis for a bit, just comparing. Here we kind of see the polls move in the opposite direction of the sentiment, which is weird, but the other half actually moves pretty well together, and we can kind of get some examples of the sentiment predicting the polls, such as like here we see the sentiment going up before the polls go up, as well as here we can see some sentiment going down and the polls kind of level out, but there's not a ton of it. So let's move on to the Trump. So he was 52% positive on retweets and 51% positive without retweets. Overall, Trump's tweets were more positive than Clinton's. However, again, we can't really see too much given the polls. So I'll normalize the data again so we can kind of see the swings in the changes in the polls. And here we actually get a pretty good look. We see the sentiment keeps going up and the polls keep going up. Here we see the sentiment drop and the polls drop. We get a good look at what the Comey, or not Comey, sorry, the Access Hollywood tape kind of did. He plummeted to his lowest polls from that in the second debate. Or not lowest polls, sorry, lowest sentiment. And here's just a comparison, the sentiment. Like I kind of talked about before, Trump, on average, was ahead of Clinton sentiment-wise. Clinton was only ahead between the first debate and the Comey letter. So Comey, the Comey letter marks the kind of Trump retaking the sentiment across both the retweets and no retweets data. So here's kind of the sentiment compared to the polls using data with retweets. This is kind of congested even without the no retweets sentiment. However, it's pretty interesting. So words that Python felt carried weight with Clinton was FBI was 4-1 negative to positive, Benghazi was 2-1 negative to positive, News was 3-1 positive. With Trump, we see Says was 4-1 negative, America was 2-1 positive, Wins was 2-1 positive, Obama was 2-1 positive. Findings of interest, we see that the average sentiment was 51% for Trump and 34% for Clinton. The test data found that the classifier was 64% accurate for Clinton, 65% accurate for Trump. The sentiment analysis, being able to predict the polls, couldn't do so very reliably, but there were instances where we did see the polls take a turn because, or not because of the sentiment, but that was a turn represented in the sentiment change, and two of those would be the Access Hollywood tape as well as the Comey letter. So Access Hollywood for Trump, Comey for Clinton, and approximately 2/3 of the total tweets were retweets, and removing the retweets from the pool of tweets dropped our sentiment by 3% for Clinton and 1% for Trump, so negatively affected the sentiment. Some reflections would be a refinement of the classifier. There were some words that were popping up that the classifier said they had either a negative or a positive connotation that really shouldn't have, like will or stuff like that. So adding more stop words would be effective, probably. And non-English tweets being removed would be good for helping the classifier. I removed them from the training data, but I couldn't figure out a convenient or a fast way to do it without going through the tweets with the actual pool of tweets. And using more lexicons. I did use some lexicons to train as well as the training tweets, but experimenting with using more positive and negative lexicons would be good. All right, here are my sources, and thank you for watching my video. I appreciate it.